My name is Nicholas Durico. I'm a solutions architect for MySQL based in the San Francisco Bay Area. If anybody attending is, from the San Francisco Bay Area, it's possible that we have met before. But if not, a pleasure to meet everybody today. And so the topic is you know, migration of Amazon RDS to the Oracle Cloud MySQL database service. And we'll cover why somebody would want to do that, but also how somebody would achieve that. So let's get started. So first off, what is the MySQL database service? So this is a new service that we've put in the Oracle Cloud, where it's a platform as a service for the MySQL database. It is if somebody is familiar with RDS, then MySQL database service, um, which we sometimes call MDS, just for short, is similar to that. But there are some very important differences that I'm going to highlight now. Well, so first off, just because it's a platform as a service, then this is designed um, to be as cloud native as possible. We've modified the MySQL database engine uh, to interact with the Oracle Cloud so that it's very easy to provision and it's well integrated with the just the Oracle Cloud in general. But also something that we bring with by combining the MySQL database with Oracle Cloud is that Oracle Cloud is we call it a Gen 2 public cloud that has a lot of enhancements in the infrastructure to enhance the security. Um, so, for example, tenancies are separated from each other and so on. And also, we build the MySQL database service that we provide in the Oracle Cloud is basically built on the enterprise version of the MySQL database that we would find on premise, but then it's modified for the Oracle Cloud. And in fact, what is the MySQL Enterprise Edition? So MySQL, we build the MySQL is an open source product, and so we have the MySQL Community Edition that everybody can download to run on premise, or we can run in compute nodes, and for example, in the Oracle Cloud or elsewhere. And then we make a version of the Community Edition that is enhanced with additional security that is useful for enterprises. And so this is the MySQL Enterprise Edition and then we use that as our basis for the Oracle MySQL database service. And so what that gives us is a MySQL database that is essentially compatible, completely 100% compatible if you go from let's say on-premise or infrastructure as a service to the Oracle MySQL database service. So an application can be written only one time, could be developed, let's say, using um, let's say a database, the MySQL database service. You could make development instances where the developers use that, and they using APIs, you can launch new instances of the MySQL database for the developers or for like a DevOps kind of purpose. But then this application would run with the MySQL Enterprise Edition on premise, or it would run in the MySQL database service in Oracle Cloud, all the same application. Something that is also different from, let's say, RDS and MySQL MDS, OCI MDS, is that we make the MySQL database service. So we make also, of course, the cloud infrastructure around it. But if you have any question or technical issues, when you open a support ticket with the Oracle Cloud, it goes directly to our uh, to the team that develops MySQL. So we have our own development team, our own technical support team, and so it's the you get basically your question or your issue goes to those same people who also make the MySQL database service, whether it's on premise or whether it's in the Oracle Cloud. So you get the maximum expertise versus versus maybe okay you have to Google your question or your technical issue. So it's unlimited unlimited number of support tickets can be created, and we have what we call consultative support as well. So you just ask, it's this, with the same support portal, you can ask questions like, how do I do my migration, or please help me to optimize my query. So all of this is included with the MySQL database service. And lastly, but some will maybe think most importantly is we also price our service to be it's basically priced for adoption, where when you see the price of the MySQL database service in Oracle Cloud, should hopefully be a no-brainer to say, oh wow, this is good, this is the way to go. And just to give you an idea of, we did some comparisons of our pricing with, let's say, the competition with their MySQL version of my, in their clouds. And this is basically, and this is not even without, we not even consider the fact that the support is by the developers when it's here, whereas the others is basically, let's say, lesser kind of support, and so on. Okay, so not even considering that, just the price itself, you can see it's about a third on average, a third of the price of the other ones. And what we've done to make it a fair comparison is that we took 100 Oracle CPUs, and basically priced the same 1 TB storage, and then using the shapes of all of the clouds, we use that as a comparison, and as you can see, you know, a third of the price. Not even a third cheaper, a third of the price. But it's not just really the, aside from the MySQL database service, just in general, the Oracle Cloud is priced for adoption. So these are numbers kind of to show the differences of what you can find in the Oracle Cloud. These are not the MySQL specific, just in general. So you see, for example, the comparing Oracle cloud infrastructure versus AWS infrastructure, essentially the compute nodes can be 50% more almost, and then it goes on like that. Especially when it comes to storage and also things like data egress, the Oracle Cloud is extremely beneficial compared to the pricing of AWS. With Oracle Cloud, the egress is free, by the way, up to 10 TB per month. So that's a huge difference right there with the other clouds. So also a quick announcement that I want to make. So we are, since MySQL version 5.7, we have built something called group replication and InnoDB cluster. And so this is going to be, this is basically the basis for our high availability in the MySQL database service. And this will be available pretty shortly with the MySQL database service. And so the way that this works is that we use a clustering mechanism where you build a cluster of MySQL servers, and that's going to be in the Oracle Cloud. And then each of the servers aware of the existence of the other server, and then they can always work together as a group. So when you write on the servers, then the update is basically pushed to the other servers for complete high availability and no data loss. In the Oracle Cloud, we some of our regions, I guess most of our regions, have multiple availability domains, which are essentially one or more data center per availability domain. And so to give even higher, let's say, durability for the data, what we do is that we will create the cluster that is going to be spread out across multiple availability domains. So it's not just the fact that we have multiple MySQL servers involved in the cluster, but also it's going to be multiple data centers involved in the data center in the high availability for the MySQL database service. These availability domains, the reason we are able to do that is that is basically it's ultra low latency networking between those data centers. Another announcement, and I'm going to talk about this a little bit more also in the coming slides, is that we build using the, let's say, the traditional MySQL. It's the Community Edition plus the Enterprise Edition, and then it becomes the MySQL database service. But in addition to that, we have also created an option that when somebody has the MySQL database service, they can enable that we call HeatWave. And this is a extremely high speed, let's say, enhancement that we put on MySQL, so that when somebody has queries that could be analytical in nature, like OLAP kind of queries, then MySQL, using the same syntax and everything, instead of running at speed X, it's going to run at speed 100 or 1,000 times X the original speed. And so it's one of the ways with the MySQL database service you can get more performance. Is that first off, the MySQL database service, we can scale up to 64 CPUs, which means in terms of Oracle CPUs, 128 threads and up to 1 terabyte of RAM. So just right there, you can get you can scale your performance just with the standard MySQL database service. But in addition to that, if you have queries that are running slowly, or that you just need way more performance for analytical, let's say, reports or anything like that, then we have an option. What the HeatWave option does is that it creates, in addition to the MySQL database service, it creates also satellite compute nodes, and everything is totally managed. You don't need to do anything, and it's fully transparent to the application. But in the background, it's going to create compute nodes that have a copy of the data that is basically stored in memory in a columnar format. And so when a query comes to the MySQL database service, the MySQL server is going to analyze the query and say, okay, this query would be better run using row format in the regular MySQL database service, and so it's going to run it like that. But if it determines that it would be better run in a columnar format, then it's gonna basically run it as such. And so what we find, and I'll show you right here. So what we've found is that we took basically the TPCH benchmarking series and of queries, and so we ran that. And I forget, I think it's maybe 21 queries. And so we did basically, the geometric means of the improvements that we see. And on average, it would be, it's 400 times faster when you turn on this option with the MySQL database service. So, it's very easy to do. You don't need to, typically if you use, let's say, RDS and you get to the maximum of what RDS can do, then the kind of best practice that is recommended by AWS would be, okay, go to Redshift or go to Aura if it's kind of a write-intensive query, write-intensive application. But for us, we don't want to have multiple tiers of MySQL services. So what we do is that you just basically enable the option, and then you get your performance that you need. So if you compare, for example, I was mentioning Redshift. So if we compare with Redshift, we did some benchmarking again using those TPCH queries. So it's 19 queries, TPCH queries, Redshift versus HeatWave. MySQL plus the HeatWave option. And basically, we did two tests. So we did the first test by using kind of being a more price sensitive on Redshift, because there's a pretty big difference, by the way, in pricing, between let's say the Amazon options and the MySQL HeatWave option. So we said, okay, let's try with the low cost Redshift and see what we get. So even with the low cost MySQL database service with HeatWave is still about 3% cheaper. And by the way, the MySQL database service with HeatWave, it's not like you need MySQL plus the HeatWave as two different things. Okay, it's still one database, so there's no ETL. There's no it's not like two services you have to pay for. It's just one service. And in this case, we would have to pay with AWS the RDS plus, the Redshift. So anyway, but it's still 3% cheaper, just the single MySQL service in the Oracle Cloud. And it's about close to 18 times faster than Redshift. But this is using the low cost. Okay, we were trying to compare on the cost. It's 18 times faster than the low cost Redshift. If we go to instead, let's compare on performance. Let's not care about cost. Let's just do the best, fastest shape of Redshift versus the Oracle Cloud MySQL plus HeatWave. So in this case, it's close to the HeatWave is close to 3 times faster than Redshift. But then if we look at the cost, then it's also close to 3 times cheaper. So it's way there's good reasons we performance and price to really consider the MySQL and HeatWave when we compare with Redshift. Okay, so now we've seen this. Okay, we say, okay, why should we go to MySQL database service? Well, because of the technical support, because it's built by the MySQL team, because it's always the latest version, because of security, the enterprise features, the compatibility with on-premise, and technically you can say even with other clouds. Anything that's, let's say, on MySQL 8 would be compatible. So when you take all of these together, but then you add on top of that the lower price and the higher performance, so it could be attractive. And how do we get there? So let's look at how we can migrate from RDS to the MySQL MDS in Oracle Cloud. So the best way the easiest way that we have is that we have a tool called MySQL Shell that we've developed to be kind of an administrative tool, and also it has NoSQL capabilities that it could act even as a development environment. So we use that now primarily to do various administrative tasks for MySQL, and migration is one of those tasks. And so the MySQL shell, the latest version, which is 8.0.22, has functions that are basically very useful for migrating from on-premise to Oracle MDS, or from RDS to Oracle MDS. And we've basically made 3 functions. So there's basically dump functions. The dump instance function basically dumps the entire RDS instance. And then there's a function that you run to load that dump file, or dump, let's say, kind of like an export into the MDS. But if you just want to dump a selected number of schemas, let's say maybe one specific schema, or a few specific schemas, then there's also another specialized function, dump schemas, that is basically you identify those schemas that you want to dump and load into the MDS. So this is kind of like the workflow that you would have here, is that you have the Amazon RDS, and then on a compute node on a EC2 instance, you could install the MySQL shell and run the dump command and the dump instance. And then what it's going to do is that it's going to push the dump from RDS to the Oracle Cloud. And technically, you could put it on a block storage in a compute node running in a OCI. But this requires to create a network link between the two clouds. Or an easier way is just to use the object storage, kind of like the Oracle Cloud as an object storage similar to S3, and so you can use that to just basically push your dump from RDS to Oracle Cloud Object Store, and then on a compute node running in Oracle Cloud, you can load that dump file, data into the MDS, and you'll see that it's pretty optimized, as we'll see in the coming slides. Okay, so how do we dump from RDS? So, well, first off, this is an overview of the dump instance command. So when you start the MySQL shell, typically we start in a JavaScript language, and there's also a Python language, so you can use both. And they both have uh, a library that we call util, and there's in the util library there's a function called dump instance, and also the load instance is there. And so you call the dump instance command, and you put basically the output URL as a destination where you want to put the dump, and this could be it could be just like a directory on the block storage, or it could be an Oracle Cloud object store. And so this is kind of these settings basically. Let's say for the Oracle Cloud object store, can be provided with the as part of the options. And there's actually a fair amount of options. So when you do your dump, knowing that you're going to the Oracle MDS, which is running on the latest version of MySQL 8, then you may want to check is your dump going to be compatible. And so we have compatibility checks that are built into the dump instance, so you can turn that on. You can also tell the MySQL shell dump instance function to perform some conversions of data types and so on that are better suited for the MDS. There's also a number of consistency options, and I'll cover that in the next slide. When you run the dump, to make sure that if the dump takes, let's say, 10 minutes or 20 minutes or whatever, that you, the dump itself is consistent, even if there's data changes that are occurring in RDS at that time. We can guarantee some consistency. And then there's also a few other options that I'll show. Okay, so first off, let's look at the compatibility checks options that we have. So when there's an option called OCI MDS, and what that does is that it tells the dump instance that the purpose is to load into MDS, because all of these functions, even though we use them to migrate data from RDS, today we talk about migrating from RDS to MDS, but they're really kind of agnostic in the sense that you can migrate from, let's say, MySQL 5.7 to MySQL 8, just in general, using those functions. So if you're going to be migrating, the purpose is to migrate specifically to the Oracle Cloud MDS, then you can put OCI MDS equals true, and then it will know to make compatibility checks specific for that service. But then let's say more granularly, um, you could say, you can tell, okay, convert if you, let's say if the source, the RDS is using like, or if it's on premise, for example, and it's using the MySAM storage engine, so you can tell the compatibility checker to convert the storage engine from MySQL, from MySAM to InnoDB. So that's one example of that. So there's a couple of things like that that can be done to help the compatibility. Also, another thing too is that you can specify tables or schemas that you want to dump. Maybe specific ones you want to dump and others you want to exclude. So you can do that. You can also just do you can also dump only the DDL. And so if you don't want to dump the data, but you still want to have some kind of the same template, so to speak, in the Oracle Cloud, so you can just dump the DDL and recreate the DDL. MySQL shell has the ability to also recreate the users as they are in in RDS, but maybe you don't want all of the users. Maybe you just want a subset of the users, so you can filter on the users. And then there's other objects like the events, triggers, and routines that you can filter out of your RDS dump. By default, everything is dumped. Okay, so you can filter things out. Okay, so I mentioned that it's a pretty optimized process. So one of the reasons why it's well optimized is because we do a lot of multi-threading when we dump. And so if you generate a compute node that's in EC2 for dumping your RDS, then it will be beneficial to use more than one vCPU. You could use, let's say, 8 vCPUs, 16 vCPUs, and then the MySQL shell will make use of those to parallel as much as possible the dump of those tables. And so we create the MySQL shell creates all these threads, and then it will assign basically multiple threads or all the tables, each their thread if possible. And then if you have some bigger tables, sometimes people have star schema databases where they have a giant fact table and smaller dimensions tables. So then what will happen is that all of the tables will get processed, but then the fact table being bigger, once the other threads are done with their tables, they're going to join their efforts to push the fact table as quickly as possible. And so you end up with potentially a directory or files that are stored in the bucket in the Oracle object store that are kind of like what we see here on the right side of the screen. So it's a bunch of files, but there's a manifest that tells what the files are that the load will use. I mentioned we can also guarantee consistency, and this is done differently in different versions of MySQL. If you use, let's say, RDS 5.7, then the MySQL shell will basically create a lock on the on the database so that it can basically select, or not select, but basically dump as quickly as possible, but also with consistency. So this is actually an option. You can tell which level of consistency that you need. If you know that it's a read-only database, for example, then maybe you don't care. You just you can you can tell it to not even create the lock. But then the nice thing is that MySQL 8, has been developed to remove a lot of those locks. So if you're on RDS 8.0, then what we're going to do is that for a very short amount of time, at the time that we create all of the threads are going to be dumping, and the time that they connect to the RDS instance. So when they connect, each thread is going to run a command called backup lock, or like lock instance in a no, there's a command to basically create a lock that is all it does is it locks the DDLs basically, so it creates transactions. So that way you have pretty much an unlocking instance. And so the initial connection that created the read lock, once all of the dump threads are ready to go, then it will unlock itself. So then your database is pretty much in a so we try to make it as transparent as possible to the application. So this is with MySQL 8. If you run RDS 8.0, the RDS with MySQL 8.0, then you would have a pretty smooth migration dumping. I think I already talked about this. Oops. Yeah, so this is an example of how you would do this from RDS. So just one thing to be aware is that to allow the creation or to run the let's say the backup lock, which is a very which only locks the DDL basically. So to allow that in RDS MySQL 8.0, you do need to run one command, which is basically the user that you're going to be doing the migration from, that you're going to be doing the dump with. You have to first give it the backup admin privilege. So this is what we have here on the screen. So you connect your MySQL shell to Amazon RDS, and then you run grant admin on that user. And then after that, you can do the MySQL dump instance, and it's going to be really fast. Okay. All right, so now we've done the dump. And let's say we've dumped it to the Oracle Cloud Object Store. So how do we move that data from Object Store to the MDS? So we have the other function, with the other side of the function, which is load dump. And in this case, you just give the URL where the dump was put, and similar options as we have on the when we dump, for like username and things like that. And so then we're going to load that in multi-threaded manners from object store to MDS. In fact, we have some similar filtering options too. So it's possible that you may dump, let's say, everything from RDS, but then when you create your MDS, maybe you create multiple MDS instances for different purposes, and you just want to load a subset of the data in each of the MDS instance. And so we've also put filtering options during the load that you can turn on. So again, by default, everything is loaded, but you can say, okay, I just want to load the DDL for this particular MDS instance, or I just want to load the one table. So you can do that. Um, the load itself is also multi-threaded, of course. So when you create your compute node instance in OCI that's going to be loading, it's preferable to use, let's say, 8 CPUs or 16 CPUs or even 32 CPUs, and then the more CPUs you give, basically the faster it's going to go. And it's kind of a similar of how the dump works, in that the threads are all going to be working on their tables. And if you have tables that are bigger that take more time, then when the other threads are done with their smaller tables, then they're going to join forces and push the bigger table in parallel as quickly as possible. And again, we can have, there's consistency options to do that. And but the main thing here is, of course, when we load, it creates transactions, so the consistency is provided, kind of automatically. But we create transactions. But what is really interesting is that we also keep track of the progress of the load. And so if for whatever reason your load was to not succeed, maybe maybe for some reason the compute node has a problem and then it's turned off or something, then we keep track of what was loaded. So the next time you run your load dump, it's going to recognize that it actually ran the load before and it stopped maybe at 50%. And so it's going to resume from the point that it stopped. So this is actually very it's very surprising. The first time you see that, if you're not expecting it, but it's very nice feature that is part of the load dump functionality. And of course, you can override that. There's options to override it, but it's pretty cool that it does that. Yeah, so this is kind of an example of the commands, and I put basically two examples at the bottom. So the first example is just if you have a directory, let's say it's in a block storage, not object store, because you could really, if it's a small database, you could decide, okay, I'm just going to dump to a directory in my EC2 instance, and then zip it, and then push it to a compute node in OCI, and then unzip it, and then load it. So you can do that, and the my dump is basically the directory name, and then it's going to go with that. Or also you could have it in, if it's in a bucket, what we do is that the files that are stored in the bucket, they're prefixed with, they would be prefixed in this case with the my dump slash name. The name of the file would be prefixed by that, so it basically acts a little bit like a directory in the object storage. And then the bucket is basically my bucket. Now, when you load or when you load from or you dump into Oracle Cloud, you can provide your credentials to do that, or you can do something called a pre-authenticated request, where you say, okay, this user for the next 1 hour or for the next week, I give that user the right, using the specific URL, to load data into the Oracle Cloud and then load from. So then it's kind of instead of providing the username and stuff, you just use a URL that is pre-authenticated for a specific amount of time. And by default, that amount of time is 1 week, but you can choose, if it's going to take only 1 hour, for example, you can make that 1 hour. And then that URL is only good for that amount of time. Okay, so let's take a look at specifically the performance that we're talking about here by using these functions. So we did some testing, but this is not really from RDS. It's more just a generic testing of our tool, the MySQL shell versus, let's say, for example, MySQL dump. So we've tested with basically three other tools out there. So there are two that are made by MySQL. One is MySQL dump, the traditional migration tool that is not single, that is basically single threaded. And then a few years back, we also made MySQL pump, which is kind of a multi-threaded version of MySQL dump. So it's faster than dump, but it's not as fast as shell. And also there's another tool, it's a third-party tool called MyDumper. That's pretty good. People have been using it, but it's not in-house. So the MySQL support team will support MySQL shell, of course, not let's say third-party tools. And so we've compared it against all of these three tools, and basically, in all cases, the MySQL shell crushes the let's say the other tools. There's one exception with the Wikipedia dataset. So we took several datasets that are kind of popular to test those things, and in the case of the Wikipedia, the data is stored in binary, and MySQL dump my dumper just basically dumps and doesn't convert, just stores binary format, whereas MySQL does a conversion. The MySQL shell does a textual conversion, but except for that one particular corner case, MySQL shell basically crushes all of the other ones. And but this is for dumping. And so what about loading? So this is also very dramatic compared to the others. The MySQL shell is much faster because it's multi-threaded and has all kinds of optimizations with MySQL to be fast. And so the MySQL shell, like I said earlier, is kind of our admin tool that we use, that we develop now for MySQL. We used to have other things like the MySQL utilities and so on, but we want to make it simpler and more user friendly. And so we've focused our efforts in the MySQL shell. So these numbers today that we have, they look, in my opinion, impressive, but they're still we're still at the beginning kind of the process. So it will get even better over time as we continue to develop more functionality and more optimizations. But aside from the dump that is fast and the load that is fast, there's another optimization that is pretty nice here, is that you can start to load while your dump is still going. And so you can almost divide by 2 the amount of time that is spent for the full process. How it does that is that when you start the MySQL load dump function, it will identify that the dump is going on, and then it will just always load as much as it can, and then if it needs to wait for the dump to process more, then it will do that. So just a few additional considerations when we migrate from RDS to MDS, Oracle Cloud MySQL Database Service. Well, first off, and considerations more like things to know, yes. So one thing that is really cool is that the MySQL shell for a few years now, we've put what we call a upgrade checker. So if you're going from, let's say, MySQL 5.7, just in general, not even the MySQL database service, but just in general, if you're going from version X to version 8, then we have an upgrade checker that's gonna basically look at 11 or 12 topics of the MySQL server, such as the data types, um, maybe the privileges, constraints, also the settings in the my.cnf file, because settings sometimes they change, with versions. So it's going to look at the settings in MySQL 8 versus what you have now, and then it's going to say, okay, this is a list of things that you may want to change, okay, that you should be aware this changed. And so this works also for the MySQL database service. So you could do an upgrade check, run the upgrade checker first in, let's say, your on-premise or your RDS instance, and say, okay, what is going on? What are the pitfalls? So this is going to highlight that. Also, we support the dump will convert data, or at least will convert the DDL, to make sure that what you have starting from MySQL 5.7.9, which is the GA version of MySQL 5.7, all the way to the latest MySQL 8, will work seamlessly to the MDS. So it will do that, but it's also not a bad idea. It's not a bad idea if you can also to perhaps, if you're going to be migrating everything to MySQL database service. Another way is that you can also upgrade your RDS 5.7 to RDS 8.0, and then you would get the advantage of or the benefit of kind of a almost lockless migration. So yeah, if you want to give this, try this kind of migration, then here's the documentation that we have. All the links, the benchmarks that I have in the demo are provided as well. These are the links to the benchmarks. How to use the Oracle Cloud data storage or object storage, and set up, let's say, pre-authenticated requests and so on. So again, it's there's a link here for that. But most importantly, if you look at the very bottom, so the MySQL developers operate a Slack channel. It's called mysqlcommunity.slack.com. And so if you have any questions on how to do this migration, then please, just come to us and ask us the questions, or reach out to any local solutions architect that you have. And it's our pleasure to, of course, to migrate anybody, especially RDS, to the MySQL database service. A few ideas for some next steps. So the best idea is if we have a 30-day trial, free trial available of the MySQL database service. Very easy. Just go to cloud.oracle.com and or actually at the bottom, oracle.com/cloud/free, and then you can start your 30-day trial for the MySQL database service. The database service is available in most Oracle Cloud regions. Just pay attention which one is available and which one is not. Over time, it will be available everywhere. Every month, we put it in the new regions. And yeah, for more information, just go to mysql.com, blogs.oracle.com/mysql. We always put the latest blog posts, latest news on MySQL. We have a Twitter account, Facebook, and so on. And of course, the Slack channel, very, very useful.